Hey everybody, so this is going to be a walkthrough of what I want you to do on this lab. Now, if you have any questions on this lab, go back and read through the procedures of this lab. So if this Ed puzzle, maybe you just kind of flew through it, not listening to it, well then you need to read the procedures and the directions from the lab itself, okay? All of it is in there. There should be no trouble with this at all, okay? Because every single thing that you need to do is written in this lab, even with the prediction question that says she went over it in class. Well, I'm gonna go over it now, but it's also in your lab. So make sure that you read this lab even after finishing this Ed puzzle, just to make sure that you know what to do, okay? All right, so this is Measuring Gravity Lab. And so a freely falling object accelerates at a rate that depends on the force of gravity. And that's what we're learning about in class right now, the force of gravity. And we measure the force of gravity, with F equals G m1 m2 over d squared, where that capital G is the universal constant for gravity. Okay, it's the same wherever you go. But this acceleration to the force of gravity depends on the force of gravity itself, right? Due to the force of gravity. So near the surface of the Earth, the acceleration due to gravity is g. And we've been learning it as 10 meters per second squared. But in this lab, we're going to be doing 9.81 meters per second squared, okay? So let's talk about what I want you to do. Okay, so you can read the background if you really want to. It might help you later on with the conclusion questions, so I suggest going back and reading this. But you can now click on the simulation. Okay, so it's a PhET simulator. You're going to go to the introduction screen. And now on this introduction screen, you're going to show the stopwatch, which you can't see here, so let me move over my screen. There you go, which is that stopwatch right here. Okay, and then let me see if I can make the screen bigger. I cannot. Okay, so let me, hold on. All right, sorry about all these issues. But what you're going to do is change this length. So right now you see it as 0.7 meters. Go ahead and change that to 1. Okay, and now let's look at the mass. So the mass is going to be told to us in the lab. So set the mass to 100 grams. Now you need to convert that to kilograms. Okay, so convert that to kilograms right now. All right, so you should have gotten 0.1 kilograms. So go back to your lab. Go ahead and move that to 0.1. That is going to be the mass for your entire lab. Now, at a certain part in the lab, you're going to have to change the length of your pendulum, but we're going to talk about that when we get there. Okay, so right now on your lab, you should have the stopwatch showing the length of your pendulum set to 1 meter and the mass as 0.1 kilograms. Okay. All right, so let's go back to the lab itself. So these pre-lab questions, in the first part of this activity, how will you determine the period of the pendulum? I'm going to talk about that when I go over the first part, okay? Prediction, at which angle will the pendulum be or have the shortest period? Okay, so at which angle do you think the period will be the shortest? And we're going to talk about what a period is in just a second, but I want you to make your best prediction. Is it going to be a high angle? Is it going to be a low angle? Prediction, at which length of the pendulum the acceleration due to gravity g will be the greatest? So length, so think distance, all right, the length from the center point of the mass all the way to the top of the pivot point, okay? At which distance will this pendulum have the greatest acceleration due to gravity, okay? Again, this is what your little worksheet should look right now, but the length should be set as 1 meter, okay? All right, so part 1, I'm just going to walk you through, but again, it's all written up here, okay? So I want you to go to data table 1. So for part 1 of this lab, we're going to set our pendulum to 10 degrees, and we're going to watch the swing time. Okay, so it has to swing back and forth 10 times, and we're going to record the time that it takes to do that. Okay, so I go to my pendulum, I set my degree to 10 degrees, and I let it go. And as you can see, it's starting to move. All right, so what I want to do is I'm going to hit the stopwatch when it hits the blue line on the right. So right now. So that's going to be 1 swing, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I know that that was a long process to watch, but it's really important that you understand that it has to go back and forth. Okay, so it starts from the right, it goes to the left, and it has to go back to the right. That's going to be 1 swing. Okay, so the time for your first swing should be around 20 seconds or so. Okay, and it's really important that you stop your stopwatch once it hits back at that 10-degree mark. So this is the point where you would record your total time, and now your total time might be different from mine. Maybe yours is more accurate. And you're going to record it right in that section box right there. Now, in order to solve for your period, you're going to take the time for 10 swings and you're going to divide it by 10. So you're going to take this time for 10 swings and you're going to divide it by 10. All right. And you're going to continue that for 20 degrees and 30 degrees. Okay. Same idea. You're going to record the time that it takes for it to move 10 swings. So that back and forth motion. All right. You're recording that time with your stopwatch. And then you're taking that total time and you're dividing it by 10 in order to get the period for each degree. Okay. Now, on the speed, fast, slow, moderate, I just want you to tell me that description. Is it fast? Is it moderate? Is it slow? You do not have to solve for anything here. You just need to tell me the description of what your pendulum looks like. Okay? All right, so data table B. All right, so this is the part where we're actually changing the length of the pendulum. Okay, so the time for 10 swings at 20 degrees. So I'm going to stop this pendulum right here. I'm going to reset my dial and I'm going to set the new pendulum. It's still at 1 meter, but now it's at 20 degrees. Okay, and so again, the same idea. You're going to stop that or start the clock once it hits that blue line. And you're going to watch it go back and forth 10 times. And again, you're going to be recording the time that it takes to do so. All right, and then once you've gotten that time, it's going to be different from what you got there. But once you've gotten that time, you're going to put it in the box here. All right, so once you've gotten that time, you're going to divide it by 10 in order to solve for the period. And then you can move on to the next line. All right, so before you solve for acceleration for gravity, go ahead and fill out both of these columns. So now you're going to stop this pendulum, and you're going to change the length of the pendulum to 0.8 using that dial. Again, you're keeping it at 20 degrees. I think that was 19, but you're going to put it to 20, okay? And then you're going to let it go, and again, recording the time for it to do 10 swings back and forth. All right, and you're going to do that for each length. All right, so we're starting with 1 meter, then we're going to 0.8, then 0.6, then 0.2. Again, recording the time for it to do 10 back and forth swings. Then taking that time, dividing it by 10 in order to get your period time. And now that we've gotten both of these columns done, we can talk about the acceleration due to gravity. So what I want you to do is go to your Desmos calculator. Okay, so on this calculator, you're going to be typing in parentheses 39.5, or is it 35.9? 39.5, okay, I'm on the right track. And I'm going to multiply that by my length. So I'm just going to represent my length with a capital L for right now, okay? You can change it as you see fit, but this is the length of your pendulum. So remember, in that data table, we were changing the length. So this number is going to change. And then we're going to close the parentheses around that, and we're going to divide it by the period squared. All right, so capital T, that period time, that shorter time. And we're going to hit the A to the 2 button to square it. Okay, so capital L, that stands for your length. This capital T, that stands for your period. So remember, if you go back to your lab, you've solved for this already. Okay, it was the total time for 10 swings divided by 10. So you're going to plug in that period time, and your length is right here on this column. Okay, so your length is going to be 39.5 times 1 meter. divided by your period squared. So make sure that you throw in that squared right there, otherwise you're going to come out with the wrong answer. Okay, and this acceleration due to gravity should be next to the accepted value. It should be around 9.81. Okay, so if it's not, maybe you were counting these swings wrong, or maybe you need to go back and check your math. Okay, all right, so all you need to do now for data table C is to copy this stuff that you have right here and paste it right into this column. Okay, and now you're going to solve for experimental error. Okay, so if you go back to your calculator, it's going to be your calculated value minus your accepted value, so that's 9.81, all divided by 9.81. Okay, I'm going to put parentheses around this. And all of that has to be multiplied by 100%. Okay, so don't worry about the percentage sign right now. Just plug in 100. Okay. Actually, you can put in percents right here. Sweet. Yeah, just put in 100. It's totally fine. Okay, so you're going to take your calculated value for acceleration minus this 9.81, all divided by 9.81 times 100%. Okay, so think back, percentages shouldn't really be negative, so make sure that your answer isn't negative. Okay. All right, so after you finish this, you would have all of your data. So now you can work on your conclusion questions. Okay, so in the first part of this activity, how did the angle from which you release the pendulum affect the speed of the pendulum? Okay, and in the first part of this activity, how did the angle from which you release the pendulum affect the period of the pendulum? So just go back and look at what you said for speed and look back at what you put for the period times and which one was the least, which one was the greatest, and why do you think so? Did your results support or contradict your hypothesis for this pre-lab? Okay, so go ahead and answer those questions. You've talked about your predictions, so now go back and answer those questions. Why might the calculated value for G differ from the accepted value of 9.81? Okay, and now using prior knowledge and the equation in part 2 of the lab, explain how the mass of the pendulum affects the period of the pendulum and the calculated value of G in full sentences. Okay, so just from what we know about the equation up above, how does the mass of the pendulum affect the pendulum itself? And if you look in the equation, is mass really there? And if we really think about it, if we're not talking about air resistance, wouldn't a rhino or an elephant accelerate at the same rate as a mouse? So does the mass really matter? All right, so make sure that you answer to the best of your abilities in full sentences. Okay, we'll go over these conclusions when I get back. All right, so good luck, everybody. Have fun with this lab. You can ask your friends for help, but just note that your stuff is going to be different. Feel free to ask the instructor for help too. I'm sure that they would be able to help you out. But just remember that the directions tell you everything. All right, so if you're wondering what you need to do, it's all in these procedure sections. Okay? All right, have a great day, everybody.